Hey everyone, this is Unit 3, Concept 1, Historical Development of the Atomic Theory. We're going to talk about a few scientists. The first guy I want to talk about is Democritus. Democritus was an ancient Greek philosopher who lived in 4th century BC. Now he was a student of Aristotle, and he was the first person to suggest that matter exists in small fundamental particles. Okay? And basically what he said was that we can divide matter again and again and again until we reach something that we cannot divide anymore. And that thing is called the atom. Now the word atom comes from the Greek word for uncuttable. So atom basically means it's indivisible. Okay? Now Aristotle, famous Aristotle, who is Democritus's teacher, actually rejected his theory. He thought that Democritus was wrong. Aristotle's idea of matter was that it can be divided infinitely. So you can divide it again and again and again, and you will never reach something that you cannot divide. Now Aristotle, we now know, is wrong. We know that the fundamental building block of matter is the atom, okay? But Aristotle is so influential and so famous that his idea is actually accepted until the 1600s and 1700s. So basically for about 2,000 years, people believed in what Aristotle said. Okay? Now, one of the first scientists to publish anything about the atoms in the 1600s and 1700s was John Dalton. John Dalton was an English scientist, and he published the first atomic theory. Basically, he described how the atoms looked and behaved. Okay? There are 5 points to his atomic theory. First, all elements are composed of tiny, indivisible particles called atoms. Second, all atoms of the same element are the same. They are identical. Third, atoms of different elements are different. Fourth, atoms of different elements combine in simple whole number ratios to make compounds. A good example of this would be water. Water is something that you guys are all familiar with. We know that it's H2O. What that means is there's a 2-to-1 ratio of hydrogen to oxygen atoms in water. Okay? And the fifth point, that chemical reactions happen whenever the atoms separate and rearrange and rejoin in different ways. Okay, now Dalton was mostly right, but there were 2 points in his theory that we now know are false. Okay? The first point, all elements are composed of tiny indivisible particles called atoms, we now know is false because we now know that an atom is actually made up of protons, neutrons, and electrons. Okay? And those subatomic particles, the protons, neutrons, and electrons, are actually made up of even tinier things. So it is not indivisible. Okay? Second, the second point in Dalton's atomic theory, all atoms of the same element are identical, is also false. Okay? We now know that some atoms of the same element will have 2 or more different forms, so they are not all the same. Alright, after John Dalton, we now have J.J. Thomson. J.J. Thomson was another English scientist. He was experimenting with something called the cathode ray tubes. Okay? Cathode ray tubes are basically a glass tube, and we have a positive electrode and a negative electrode, and we are passing a beam of electricity through the electrode. Okay? Now, he was experimenting with these cathode ray tubes, and what he did was he put a wheel inside the cathode ray tube and just to see what it would do. Okay? And what he found out was that the electricity, when it's passing through the wheel, the wheel would rotate. Okay? And second, he used a magnet and he pointed it at the cathode ray tube to see what it would do, and he saw that the electricity beam would actually bend away from the negative end of a magnet. Okay? So these are his observations. What do they all mean? Here are his conclusions. First of all, he concluded that something in the electricity has mass. Okay? The beam is not just pure energy. It rotated the wheel that was inside the cathode ray tube, which means that there's something that's hitting that paddle. It's hitting the wheel. So there must be some particles that's inside the electricity. Okay? Second, particles in the electricity beam must be negatively charged. Why? Because the magnet that he pointed at the beam bent away when it was the negative end pointing, okay? And we know that like charges will repel, so when we have a negative pointing at a negative, they would actually want to go away from each other, okay? So from this, J.J. Thomson was able to conclude that this must be a negative particle, and this was the discovery of the electron, okay? Now, what was so important about all this, other than discovery of the electron? Thomson was able to come up with a theory of what he thought that the atom looks like from this, okay? It was known at the time that atoms have an overall neutral charge. They have no charge. So if there's a negative particle inside the atom, then there must also be a positive particle inside the atom, okay? So from that, Thomson came up with what's called the plum pudding theory. Okay, what he thought was the plum pudding, or the atom, looks like a plum pudding, and a plum pudding would be something like a fruit cake. So think about his theory basically says the atom is like a fruit cake. Okay, the cake part is positive, it's solid, so the atom is solid and positive, and all the raisins and the fruits that are inside the cake, that part are the negative particles, what we now call the electrons, that are inside the atom, and they're just scattered really randomly, okay? So this is known as the plum pudding theory. Now we know that the plum pudding theory is actually wrong, but at that time it was a breakthrough, okay? And most people believed in it because the data supported that. Until we get to Ernest Rutherford. Ernest Rutherford was another English scientist, and he did what's called the gold foil experiment. Basically what he did was he took a radioactive element and put it inside a lead box, okay? And when the radioactive element decays, it actually releases a particle that is positive, and we call that the alpha particle, okay? So this positively charged particle was released, and he directed them towards a sheet of gold foil, okay? So when the particles go through the gold foil, he put a screen right on the other side of the gold foil so he can see where these particles are going to hit, okay? Now if the plum pudding theory was correct, then all the alpha particles would just go straight through the gold foil. But that's not what he saw. He was really surprised when he looked at his observations and when he looked at his data. Because what happened was most of the particles went straight through like he expected, but some of them actually went through but had kind of a bent path, all right? And then there were some that actually bounced back all the way. So this really surprised him. And what he was able to conclude from this was that the atom's actually mostly space. That's why all the particles can go through. But there were some that were hitting a spot in the atom that is dense and is positive, okay? Because these particles are positively charged and they're bouncing back, then that means that they must be hitting a positive thing. So that's why they're bouncing back. Because if they're hitting a negative thing, they would be attracted to it and they would not bounce back, okay? And he called this area the nucleus. So now we have the nucleus inside the atom, and the atom is actually mostly space, okay? All right, now let's get on to the electrons. Now we know that there's a nucleus. Let's talk about the electrons. Where are they? Okay. One of the first people to think about where the electrons would be was Niels Bohr, right? Niels Bohr was a Danish scientist, but he was working in England in the 1800s. He actually thought that electrons would orbit the nucleus just like how the planets would orbit the sun. And so we call this theory the planetary theory. So this is what he thought the atom would look like, okay? The nucleus is inside, in the middle, and the electrons are just going to circle around the nucleus in different levels. All right. Second person that was very important was Max Planck. Max Planck was a German scientist, and he came up with what's called the quantum mechanical theory. he said that electrons don't orbit. Electrons don't go in circles, okay? They actually move really randomly in what's called an electron cloud, and where they are depends on how much energy they have. Well, who's right? We now consider Max Planck to be more right, okay? But we don't completely dismiss Niels Bohr's idea, because Bohr's idea of the levels really helps us understand how electrons behave. And we're going to talk more about electrons at a later time, but for now I just want you to know that electrons do have those levels like Niels Bohr thought, but they also move randomly like Max Planck said. Okay, so both theories are kind of right. All right, we kind of have an agreement in between. Okay, next guy, James Chadwick. We've discovered the electrons and we now know how it looks and how it moves. We know that there's a nucleus and it's positive. Okay, what James Chadwick was able to find was that he calculated the mass of the protons and the electrons, and he found that it actually didn't match up with the total mass of the atom. So what he thought was, well, there must be something inside the atom that is neutral, but it has a mass, okay? And he called this the neutron. So now we have all three of them. We got protons, neutrons, and electrons. All right, and finally we have Henry Moseley. Henry Moseley was another English scientist, and what he did was he used X-ray to figure out how many protons are in each of the elements, okay? And what we now call that number is the atomic number. Alright, so putting all of this hundreds of years of research and scientific understanding together, we now have the modern atomic theory. Okay? Modern atomic theory says that matter is composed of tiny fundamental particles called atoms. They are not indivisible, but they are fundamental. Okay? Atoms have two areas. There's a positively charged dense central area that we call the nucleus, and there's a part where the electrons move that's outside of the nucleus, and we call that the electron cloud. Okay? The nucleus has positive protons and neutral neutrons. Therefore, the nucleus is positive. And the electrons are negative and they move randomly inside the electron cloud.